Hello, my name is Nikhil Naik and I'm a speaker at the CMSA Big Data Conference this year. At the conference, I spoke about my work on understanding urban change using computer vision algorithms and street view data. Social scientists have been interested in studying urban change for several decades now. And while there's a lot of data on how the socio-economic composition of cities has been changing, there's less data available on how the physical infrastructure of a city is changing. So things like how much change has been happening in the streets, in the buildings, and landscaping and so on is less readily captured in government data than the data on how a neighborhood is changing in terms of socio-economic composition. So a new source of data has become available in the past decade on the physical appearance of cities, and that is Google Street View. Google cars have captured cities across the world for past 10 years now, and this data in terms of time series images is readily available for research. So we developed a computer vision algorithm which can access these images and process them to tell you how much a place has improved or declined in its physical infrastructure. Specifically, our algorithm looks at two images from the same place captured 7 years apart and assigns it a number based on how much the place has undergone improvement or decline. We run this algorithm called street change on more than 1.5 million street block images from 5 American cities: New York, Boston, Washington DC, Baltimore, and Detroit. We aggregate this data at the census tract level and correlate it with socioeconomic composition of these census tracts. So the question we are interested in understanding is that what socioeconomic factors are best predictive of physical growth in neighborhoods. And we find three important findings. In the first finding, we see that education and population density are the most important predictive factors of future physical growth in neighborhoods, and not things like housing cost or ethnic composition or the income levels. Secondly, we find that location is also an important factor in predicting future neighborhood growth. The distance to downtown and the location as being surrounded by other nicer neighborhoods are also two very important factors in predicting future growth of neighborhoods. The third important factor or fact we discover is that the so-called tipping theory of neighborhood change is also quite true. The tipping theory says that neighborhoods that are already doing well, they keep improving at a larger pace, while neighborhoods that are not doing well may not improve as much. And in our data, we find a linear trend in the initial state of the neighborhood and how much improvement it undergoes in the sample that we study. So in summary, we introduce a computer vision algorithm which can analyze two images of a location from Google Street View taken several years apart and quantify how much the place has improved or declined. And using this data, we study the socio-economic predictors of neighborhood growth and decline.